Hello everyone. Today we will going to discuss about the remainder theorem. First of all, what is remainder theorem? Remainder theorem will go if a polynomial p of x is divided by x minus c. The quotient is q of x and the remainder is r. The relation is defined by p of x is equals to q minus x minus c q of x plus r, where q minus c is the divisor, r is the remainder, q of x is the quotient, p of x is the polynomial. If r or the remainder is equal to 0, q minus c, therefore q minus c is a factor of px. Like in this equation, we can see that if the remainder is 0, cannot be seen in this equation, and therefore we can conclude that x minus c, or the divisor, is a factor of the polynomial x. Then next, let x be c. P of c is equal to c minus c q times q of c plus r. And the next, p of c is equal to 0. Why 0? Because c minus c will result into will have a product or have a sum of 0, and that q of c and then remain the same, and then r will also. And when we simplify it, any term that will multiply to 0 will have a product of 0, so that the term that remain on the equation is only r. So the final equation will be p of c is equal to r. So therefore, substituting c to x can be used to determine the remainder of a function, not only using synthetic division or long division. Yeah. So next, we have problems for us to solve and to test our new knowledge that we've learned. So problem number 1. Find the remainder when p of x is equals to x cubed plus 5x minus 4 is divided by x plus 3. So the solution for this problem is when p of x is divided by x plus 3, the remainder will be r is equals to p minus 3. Why? Like we discussed before, we can also use the remainder theorem to determine the remainder, not only using synthetic division or long division. So the next step is like this one, we just need to substitute the c to the value of x. So the value of c is negative 3. Why? When x plus 3, and when we transpose the positive 3 to the other side, it will change into negative 3. So then it will turn in this equation. So p of negative 3 is equals to negative 3 cubed plus 5 times negative 3 minus 4. Then we simplify it. Negative 3 cubed is equals to negative 27. 5 times negative 3 is equals to negative 15, and then 4. Yan. So we need to simplify these equations, and negative 27 minus 15 minus 4 will result into negative 46. So the final answer for the problem is the remainder of p of x is negative 46. Yeah. So the problem number 2, find the r of p of x is equals to x cubed plus 5x minus 4 when it is divided by 3x plus 1. So we can see on the polynomial, we just use the polynomial of the problem number 1 for us to look the difference between if we have two different divisors. So the solution, when p of x is divided by 3x plus 1, remainder will be r is equals to p of negative 1/3. Why? Because when 3x plus 1, when positive 1 will transpose on the other side, it will change into negative 1. And then for us to isolate the x in the divisor, we need to divide the leading coefficient of the leading term, or the leading coefficient of the x, which is 3. We need to divide 3 into negative 1 for us to isolate the x. and then the result will be negative 1/3. Then And next, we just need to substitute the value of c, which is negative 1/3, to the whole polynomial of x. Next, it will turn to p of negative 1/3 is equals to negative 1/3 cubed plus 5 times negative 1/3 minus 4. Then it will turn to negative 1/27 minus 5/3 minus 4. And then when we simplify this equation and when we got the common LCD and then we solve it, or and we solve it, it will result on negative 154/27, or negative 19/27 in mixed fraction. So as a final answer, the answer for the problem number 2 is the R of P of x is negative 154/27, or negative 519/27. So for the last problem number 3, the expression x cubed minus kx squared plus 5x plus 3 leaves a remainder of 5 when divided by x minus 2. Find the value of k. So in this case, we don't need to find the value of remainder, but we need to find the value of k. So in this case, let p of x be p of c. Why? Because in the previous in the intro, we discussed that p of x that divided by the divisor using synthetic division or long division is also equal to p of c. So that's why we can form an equation of p of c is equals to p of 2. Why p of 2? On the divisor x minus 2, we transpose the negative 2 on the other side, and it will turn to positive 2. And then positive 2 will be the value of c, and that's why p of c is equals to p of 2, because c is equals to positive 2. And then the value of c will substitute to all the value of k in the polynomial. So p of 2 is equals to 5. Why? Because as in the intro, p of c will also result into remainder. So it's given on the problem that it leaves a remainder of 5. So that's why this equals to 5. So the whole polynomial will equate to 5 for us to find the value of k. So it will result to 5 is equals to 2 cubed minus k 2 squared plus 5 times 2 plus 3. And then we simplify the x and we solve the exponents, and will result to 5 is equals to 8 minus 4k plus 10 plus 3. And then when we solve the terms without variable, will result to 5 is equals to negative 4k plus 21. And then we need to transpose the positive 21 to the other side, on the 5 side, and then it will become negative 21 plus 5. And then when we solve it, negative 21 plus 5, it has a sum of negative 16. And negative 16 and then it will become in this equation negative 4k is equals to negative 16. Then for us to find the value of k, we need to isolate the k. And for us to isolate the k, we need to divide the value of the leading coefficient of the k, and then that is negative 4. And then we need to divide it on the other side, and the negative 4 over negative 4k over negative 4 will be cancelled out, and will be k only. And then negative 16 over negative 4 will be positive 4, and that's the value of k. And sa final answer, the value of k is positive 4.